Hi, welcome to this lesson on number patterns, infinite geometric series. In this one, we're going to be looking at question 3 of solving an infinite geometric series problem. They want us to determine the value or values of x, so there could be more than one, in the geometric series that will make this series converge. So we have 3 plus 3 over 2 times x minus 1 plus 3 over 4 times x minus 1 all squared plus and so on. So let's see that this is geometric, right? The first term a is 3. How do I find the common ratio? So I'm going to use common ratio equals t3 divided by t2. In that case, it's 3/4 x minus 1 all squared divided by 3 over 2 times x minus 1. Well, this x minus 1 squared and x minus 1 will cancel out. And then 3 divided by 3 will cancel out there. So you have 1/4 x minus 1 divided by a half. Dividing by a half is the same thing as multiplying by 2. So therefore I get 2 times 1/4, which is a half, and that's times x minus 1. If I do t2 divided by t1, I should get the same r value. Let's just check that. So t2 is 3 over 2 times x minus 1, all divided by 3. The 3 will divide into the 3, and you're left with a half x minus 1 in the numerator. So therefore, these two values are equal. Therefore, that is the common ratio, constant ratio r, a half times x minus 1. So they want us to find values of x that'll make this series converge. So remember, convergence only happens when your constant ratio is between -1 and +1. Okay, but we have an expression for r. So we can rewrite that as -1 less than a half times x minus 1 less than 1. So I want to isolate x by itself, so I'm manipulating a linear inequality here. So first, to get rid of the half, I multiply both sides by 2. So -2 is less than x minus 1 less than +2. To get rid of that -1, I'm going to add 1 to both sides. So -2 plus 1 is -1 less than x less than 2 plus 1 is 3. So there are your x values. Your x values are between -1 and 3, and x is a real number. That is the inequality notation. Alternatively, you could write it in interval notation. X is an element between -1 and 3, not including those points, so round brackets. So whenever your x is between -1 and 3, this series should converge. And let's test that. So on the number line, -1 and 3, open dots, and you want to be between here. So let's pick a number between -1 and 3. Let's pick 1. 1 is between there. So if x equals 1, then it's saying that if we put 1 in here, this thing should converge. Let's test that out. So let's clear everything up here. So we know that we said x must be between -1 and 3. So we're going to choose x equals 1. Right? We could choose any x value between here, and it'll always give you a convergent series, but let's just test it with 1. So 3 plus 3 over 2, well, 1 minus 1 is 0. Plus 3/4, 1 minus 1 squared is 1 minus 1 squared is 0. So if we keep doing that, it's going to be 3 plus 0 plus 0 plus 0. That is a very boring thing, but it does converge to a finite value. Converges to 3. Okay. If you chose x to be, let's say, a half is between -1 and 3, then here you would get 3 plus 3 over 2, a half minus 1, plus 3 over 2, a half minus 1 all squared, plus so on. That converges, and we can see that because the general form will be Tn equals. So let's just clean this up a bit here. Well, we know what Tn will be. It is a times r to the n minus 1. R was a half times x minus 1. So a is 3. R is, so if I put a half in here, I'm going to get r equals a half times a half minus 1. Half minus 1 is -1/2 times a half, so I'll get -1/4 to the n minus 1. So that's what that sequence ends up looking like. And if we add that up, we know that S infinity is going to be a over 1 minus r. which is 3 all over 1 minus negative a quarter. That becomes 3 over 1 plus a quarter. 1 plus a quarter is 5 quarters, and when you divide by a fraction, you multiply by the reciprocal. So I get 12 over 5. And that is the finite value that the sum would converge to if x was a half in this case. Okay, so any x value between here will make this algebraic geometric series converge. All right, I'll see you in the next one.